right, here we go. Find the partial fraction decomposition. We have an x to the third over an x to the fourth. So we don't have to do long division. And then we kind of ignore the fact that it's really x to the fourth when we set it up. And here's how these work. To decide whether you divide or not, you look at what it would be if you multiplied all this out. Like I said, x to the fourth if we multiplied it all out. But then to set it up, we ignore the fact that this would be x to the fourth, and we just look at, well, that's an x squared. And the top is always one less power than the bottom. So if the bottom's a quadratic, we're going to make the top linear. We're going to put ax plus b over x squared minus 3. That's the first step. Then we have to do plus cx plus d over x squared minus 3 squared, like that. So that is set up, that is ready to get common denominator and finally solve. We need to multiply this one by x squared minus 3 on top and bottom. I usually just write it on top, by the way, assuming you know that it's top and bottom. Now everybody has the same denominator. We have x to the third minus x equals, I need to FOIL this, or distribute the ax through, ax to the third minus 3ax, then distribute the b through, plus bx squared minus 3b. That's the same as FOILing, just distribute twice. And then we have plus cx plus d. Well, now this is equal to ax to the third plus bx squared. So there's the x to the third. There's all the x squareds, which is only 1 in this case. And then plus negative 3a plus c. That's the x's. And then that's x's minus 3b plus d. So there's all the powers represented, all the way down to the constants. Well, here's what you could do. You have a is equal to 1. That's the coefficient of the x to the third. B is equal to 0, because on the left we don't have an x squared. And then we have negative 3a plus c is equal to negative 1. Well, we know what a is. Negative 3 times 1 plus c is equal to negative 1. C is equal to 2 when we add the 3 over. And then negative 3b plus d is equal, how come I have negative, is that right? Yeah. Okay, I got it. Is equal to the no constant, 0. Well, we know what b is. Negative 3 times 0 plus d equals 0, so it turns out that d is 0 also. So we have the a, b, c, and d. Now we can answer the question. But what if we got to a place, what if there were lots of stuff going on here and it was getting too complicated? Here's what you could do. You could say a plus b plus c plus d must be 1. Then on the next one, a plus b plus c plus d has to equal 0. That's for the x squared. So the top one's the x to the third line, the x squared line. For the x line, you could do negative 3, 0, 1, 0, negative 1, right? Because no b and no d, no b and no d. And then the last one says 0, negative 3, 0, 1, 0. Now, because there's lots of zeros up there, that'd be the long way to go. But imagine if those were all filled in. Just plug it into your calculator, plug that into your calculator, do RREF, reduced row echelon form, it'll spit the answer out for you. But this one is very straightforward in my opinion, right? You agree with that? That's not worth typing all that junk into the calculator. But if you get one that becomes a little bit too complicated, throw it in the calculator, no problem, this will be on the calculator part of the test. Am I making myself clear when you should and when you shouldn't plug it in the calculator? All right, this one was very straightforward. All right, we haven't written the answer yet. We got x plus 0, ax plus b, a is 1, over x squared minus 3. C is 2, so 2x and d is 0, over x squared minus 3 squared. There's your final answer right there. Cool. Good stuff. These are pretty algorithmic. It's the same stuff over and over again. Find the partial fraction decomposition. That's an x to the third over an x to the fourth. Do not have to do long division. But now I have ax plus b over x squared plus 2x plus 3 plus cx plus d over x squared plus 2x plus 3 squared. We treat those as if they're quadratic rather than treating them as if they're x to the fourth. Now I have to multiply this by x squared plus 2x plus 3 on top and bottom, of course. And now that we have all the denominators the same, we don't need them to solve this. Run the ax through. Ax to the third plus 2ax squared plus 3ax. There's running the ax through. Run the b through. Bx squared plus 2bx plus 3b, and then plus cx plus d. Ends up being a mile long. We already know a is 1. That's good. But we have ax to the third plus 2a plus b. That's the x squareds. I need x's. 3a plus 2b plus, well, what's that over there? Oh, that's a c. I thought it was a parentheses for a second. Cx. Let's see, I got the x here, cx, and then plus 3b plus d. What did I do? I didn't write the x squared. X squared right there. Got to squeeze it in. A is 1. It looks like I probably won't have to use a calculator for this. But if you did, this line would be 1, B, C, D, 1. That would be what you would enter into the calculator if we were going to take that route. I don't think that's necessary here. 2a plus b should equal 4, but we know what a is. 2 plus b equals 4, so b equals 2. 3a, that's 3. 2b is 4 plus c is equal to the coefficient of x, that's 7. So c ends up being 0 after all. We know what b is, so we have 6 plus d is equal to 9. D should be 3. A is 1. So x plus 2 over x squared plus 2x plus 3. C is 0, so we have 3 over x squared plus 2x plus 3 squared. Good stuff. And I thought we'd do one where we actually have to divide. Now, here's the problem with these. If you forget to divide, you can work it the exact same way, and you can get an answer that is completely wrong. That's the bad part. You can continue on, get values, give me an answer, all wrong. All right? So you have to remember to divide here. X squared minus x minus 2. 2x squared plus 6x minus 11. And usually this long division only 1 or maybe 2 steps at the most. 2x squared minus 2x minus 4. We have to subtract. 4x minus 7. We're saying that this is equal to
8x.
What did I do wrong? Oh yeah, 8x, okay. Minus. Thank you. We're saying that this is equal to 2 plus 8x minus 7 over x squared minus x minus 2. That's what we're making the claim. Well, that's like saying 7/4 is 1 3/4. It's the same claim. Just has some variables with it. We need to factor this, x minus 2, x plus 1. We're doing the fraction decomposition on the fraction part. This is equal to a over x minus 2 plus b over x plus 1. Now this needs an x plus 1. This needs an x minus 2 on top and bottom. So 8x minus 7 is equal to a times x plus 1 plus b times x minus 2. And on these ones that are linear and very, very straightforward, I do a little different process. I don't worry about distributing through. I'm just going to let x equal -1. Make that 0. So we have -8 minus 7 is -15 equals -3b. So b is 5. And then we can let x equal 2. 16 minus 7 is 9, and that's going to be 3a. A is 3. So the final answer is 2 plus. Don't forget to bring that with on the answer. I can see how, hopefully you can see how easy that would be to forget to write that. And then we have 3 over x minus 2 plus 5 over x plus 1. Now, if you're looking at the solutions and they have their a as 5 and their b is 3, they're going to end up putting it over the same factors. So don't worry too much about your a and b, just worry about did you get the answer right rather than did you have it the same way. It can be either way. Graphs of inequalities is a very quick review on graphing inequalities. Here I would use x and y intercepts. They both would be 10. The y-intercept here would be 12, and the x-intercept would be 4. So x-intercept is 4. Well, let's use a different color. 4 and 12. So I use green for that one. And then red, oh, I didn't draw the line. That'd be helpful. Something like that. And then how about red for the last one? The x-intercept would be -6, but I don't have a graph for negative. I don't have the graph over there at -6. So let's do slope-intercept form here. Divide by -3, so that's greater than or equal to negative. Not negative, but it'd be negative over negative. 1/3 x plus 2. So y-intercept of 2, up 1 over 1, 2, 3. 1, 1, 2, 3. 1, 2, 3. Now imagine putting all of these in slope-intercept form. If I put this one into slope-intercept form, I would not have to divide by negative. And on this one, I would not have to divide by negative. So putting them in slope-intercept form would not change the sign. When you are in slope-intercept form, the sign tells you either above or below. So below, above, below. So below the blue, then I went to green. Above the green, and above the red, because it ended up being greater in slope-intercept form. Now we like to always assume that this area is always inside that little triangle there. Anytime we see a little triangle, it's an automatically, oh, it must be inside there. It's this knee-jerk reaction. But if I made this below the red instead of above, the area would be here. So don't assume right away that it must be that little triangle in the middle. That's a common misconception. I will admit most of the time it is. That's the problem. Because you get lulled to sleep. You're like, well, it's always in that triangle. And all of a sudden, bam, they put it down there. Like, I got you. I don't want to get you. I want you to do it right. Well, that's it. Bye, YouTube.